Welcome in, everyone. Happy Monday. We are going to be doing some algebra worksheets, okay? We're going to be doing linear versus nonlinear, x and y intercepts, and so on, okay? So if you know anybody struggling with these topics, please share this live out. Double tap your screen. Let's get started. So number one says, which equation represents a nonlinear function? Okay, so first you would have to understand what linear means. Linear is any equation y equals mx plus b, okay, in this form. So if we're looking for nonlinear, C would be our answer because x to the third is a nonlinear. All the equations with just x, or see this equation y equals 4 is linear too because it's just a horizontal line. So it's really a line is linear. Okay. All right, let's go to number 3. Is this table a linear function? What do you guys say? Yes or no? Is it true or false? What do you guys say for the table? Now, linear means that you're looking for a pattern. When you're looking at a table, you're looking for a pattern that adds. You can add by a positive, you can add by a negative, but it must be adding, not multiplying. Oh, okay. Lice pre-nurse. You just had this. Okay, wonderful. T. Howe said yes by 25. I love it. So let's see how this is increasing. Okay. So 125 plus 150. Perfect. It's increasing by 25. On here, this side is increasing by 1. So this is a linear function. So it is true. The table is linear. Okay. What about number 5? Which of the following is a linear function? So this is asking us, out of all these equations, which one is linear? Yes, pre-nurse. I do separate tutoring, one-on-one appointments. You can click the link in my bio and sign up there. Lauren said A. I love it. Beautiful. All right, beautiful. So, yes, A is a linear function. It's in the form y equals mx plus b, okay? Does anybody know what this equation, what's this? We know it's nonlinear, but do you know what the specific name is? Yep. Good, parabolas. Standard form. Okay, so this is a quadratic formula because it's x squared. Okay, so other people might call it a parabola. This 1 over x. This is exponential. Okay, number D is exponential. And then this is a rational. Okay, so if you're in college algebra, you would need to know the names of these. Okay, but this is just algebra 1. Freshman year. All right, let's go to number 2. So which graph represents a linear function? So is it A curve opening upwards, B, a straight line with a positive slope, a V-shaped graph, or a U-shaped graph? Hi said B, B, B. Wonderful. Good. A straight line. Yes. And B is our answer. Linear is always straight. Okay. Number 4, is this graph a linear function? True or false? False. Good. It is a false. Yes, this is false. Perfect. And I also see for number 2, I see people saying a curve opening upwards. People are saying this is an exponential function. Perfect, because it would look something when they say this. It would look like this. A curve opening. A V shape is absolute value. And then a U shape is a parabola. And then, so this would be the equation. It would be y some base a to the x. Okay. And I'm telling you, the more you have your base function memorized, the better it is, especially for college algebra. All right, let's go to number 6. Okay, number 6. So identify the non-linear function. Okay, so the I messed up on here. I should have said select all. This should be a select all. B, good. B is. Does anybody else see the B? Lauren, B, Andy. Yes. This is non-linear, guys, because the x is in the denominator. So this should have been a select all problem, B and D, or I need to change this to like 5x. Okay. So good. All right, beautiful. Okay. So we're just going to run through these. Hopefully everybody's catching on. Linear versus non-linear. If it's a straight line, right? Graphically, it's linear. So number 7 is a straight line. See, number 4 had curve. If it has a curve, it is not. It has to be straight, okay? So number 7 is linear. Straight line. Number 9. What do you guys say about number 9? Is it a function or not a function? I mean, I'm doing function versus non-function. Is it linear or non-linear? No, no. Good. Thank you for the roses. Thank you, thank you. So non-linear because of the x to the cube, right? It's a cubic function. Number 11. What do you guys say? Non-linear. Beautiful. Good. Even though it kind of almost looks like it, remember it has to be straight, right? It has to be straight. So this is non-linear. Okay, non-linear. It's not a straight line. What? Okay, now let's go over here. Number 8. Is the table linear or non-linear? No worries. Good. You guys are answering, is it a function or not a function? Beautiful. Yep. Linear. No, no. Ooh, we're getting some linear, some not. So how you do from a table, remember you have to look at the pattern. So here we go up by 2. But from 5 to 11, we go up by 6. And since it's not increasing by 2, here this is increasing by 1. And since it's not increasing by the same number, this is non-linear. Okay. What about number 10? Yeah, somebody said I was looking at the x. Yes, the x can be constant, but both sides have to be constant in order, like they both have to add by the same number in order for them to be non-linear. Okay. So linear, yes, good. It is linear in the form y equals mx plus b. Okay. What about number 12? Is number 12 I said, hi, Perez. I hope you had a wonderful weekend. No, nonlinear. Beautiful, you guys. So number 12 is nonlinear because the x is in the denominator, right? So that will be our reasoning. All right. We're almost done with this. Quick and straight to the point. We have another table. So for number 13, what do you guys say? Is it linear or non-linear? I see non-linear, question mark. Okay. I'm seeing a whole bunch of non-linears. Well, let's see. So in order for us to get from -10 to -4, we're going to add 6. And then from -4 to 0, we're going to add 4 and then add 4. This is the trickery part, right? It looks like it's, 4, 4, but this first part wasn't just 4. And then this side, well, right there, sir. So this is nonlinear, okay? Number 14, it is a straight line. Yep, rate of change isn't constant. Beautiful. Straight line, it's going to be linear. It's a straight. And then 15. Does anybody know what type of parent function this is? What's the parent function for this? Good. Somebody said it's linear and it's negative slope. Beautiful. Sean said absolute value. Let's go. Yes, it is. So this is non-linear. Perfect. All these are absolute value functions. U's are parabolas, quadratics. Okay, perfect. All right, we have domain and range. I know a lot of people struggle with domain and range. It's just one of them topics that if you see it, you got it. If you don't, it's just tough, right? So, number 1. Okay, Sean said all real numbers. I love it. So what is the domain of the function f of x equals 2x plus 3? A. Perfect. Remember, this is a line. So no matter what the line looks like, it's going to be something like this. Either like this or like this, but it's a line. And in the domain, if we're looking at a line, it keeps on going for the x's all the way to the left and all the way to the right. So the domain of every linear function is going to be A, all real numbers. Any questions on that? Thank you, Unapologetic, for sharing the live. Thank you. All right, let's go to number 3. What is the range of the function? Yes. So why it's all real is because if you look, let's just go back to if we look at this line, right? What it's saying is domain, first off, let's talk about what domain is. Domain is the x values. So you see how this line is going to go on forever and ever towards the left? And then it's also going to go on ever. It continues forever to the right. So that's why it's all real numbers, because it never has a break. It's going to continue to the left and to the right. So it's all real numbers. That's why. Okay. Now, range, we're dealing with the y-axis. Okay. Whenever you think about range, it's the y-axis. So if we look at number 3, what is the range of the function? D, D, D. Good, you guys. Good. So if we look here, we're looking at the y, okay? We're looking at this point right here. This point is -3 on the x and -3 on the y, okay? Now, when we look at the range, we're only looking at the y's. So this function, the lowest it will be is -3 on the y, and then it goes all the way up. Because there's arrows here, this will continue going up, up, up forever. So, and it's not an open circle, it's closed, so that's why it has to have the equal sign here. And D is our answer. Y is greater than or equal to -3. So we look here at the y, it's -3, and it goes all the way up. Okay. Okay. All right, let's go to number 2. Number 2. What is the range of the image? Do you guys get A, B, C, or D? What do you guys say the range is? Okay, I see C come in. Remember, you got to think about what is range. Is range x's or are they just y's? So the range is we're looking only at the y-axis, right? So here we have a point that's on the y, that's going to be a 5. Here we have a 2. Now, this is the one that's tricky for a lot of people, but the y here is 0 right here. And then this is -2. So if we start with our lowest, it will be -2. So we know this A is out. Okay, because we're looking at the -2. Here is 0 on the y-axis. And then here we have 2. And here we have a 5. That is our y's. So actually B is our answer. See, C mixed the domain and the range together. See, the domain is when you look from the x-axis. So that's how they're getting -1, you guys. That's how they're getting 2. And that's how they're getting 0 here and 1. If you look from the x-axis. Does that make sense, you guys? Does that help? Hey, Steph, what are you working on in geometry? What are you guys working on right now? Good, good. All right, let's go to number 4. Okay, good. We got more of these. Graphs right now? Okay. That's exactly what I was saying. I think the more you practice, like it's literally, you have to understand, like you're looking from the y-axis, right? Versus the x-axis, which is the domain. And the more you practice it, the better you'll get. But that's literally how I got better, is I had to draw like, okay, I'm coming from this axis. So what are the points that I'm looking at? What is the range here? Remember, this is a linear function. It's y equals mx plus b. If you have that linear function in your head, right? This is a picture of a linear function. It's going to go all the way down to infinity and all the way up to infinity on the y-axis. So if you said A, perfect. All reals. Okay, all reals. All right. Let's keep it going. Okay, so this one says, what is the range of the function here? Okay, what type of function is this? What does this look like when you have an x squared? Does anybody know? What shape are we looking at? when we have x squared. A quadratic. Chloe, yes. A quadratic. So if you know your base shapes, right? Boom, boom. Okay, this is my X. This is my Y. So I know it's going to be a U shape. This -3 says it drops it down 3 spaces on the y-axis. So it's going to look something like this. This is the rough draft, okay? It's going to look something like that. So my range here, the lowest number it's going to be is -3. So I know C and D are out, and it has to be either A or B. Well, it's it's going up. So it has to be A. Okay. It has to be A. All right, because it's starting at -3 on the y-axis, so that tells me here. And then understanding, since it's going up, it has to be greater than. This is less than. It would have to be going down if it was less than. Any questions on that, you guys? Any questions? Oh, okay. Oh, okay, I think I'm getting it. How did you know it's going up? Great question. How I knew it was going up is because it's a positive X right here. Whenever the A, they call this the A. Whenever the A is positive, it goes up. If it was a negative right here, then it would go down. And that's what you'll learn when you learn transformations. Okay. All right. Okay. So for number 7, it says find the domain and range of the function. Okay, so we want the domain and range of the function. What do you guys say? Oh, you're so welcome. Great question. It just depends. Like if you start to hear my babies in the background, I jump off. Oh, you're so welcome, Perez. Good. So somebody said, I don't know. All real numbers, Monique. Let's go, Monique. Okay. You guys, don't forget to grab your heart me for today. Thank you so much for the gift, hun. Thank you, thank you. So this is a linear function. It's a linear because it's in the form of y equals mx plus b. Well, we know all linear functions are going to be lines, okay? So if you have a line, the domain for all linear functions, remember, if we're looking, this is going to go to the left. It's going to go to the right forever. All real numbers. Okay. Range, if we look at the y-axis, it's going to go up forever and it's going to go down forever. So it's all real numbers. And it just helps if you know, again, all lines are going to have all real numbers for domain and range. That's always, okay? When it's an equation. All right, let's go to 6. Thank you for the follows, you guys. Thank you for the gift. Thank you, thank you. All right, so number 6. What is the domain of the function? So, some of you guys might not have known what this is. This is a piecewise function. When you see a function like this, it's a piecewise. So we're looking at the domain. What do you guys think? Is it A, B, C, or D? What do you guys say? D, D, D. D, D. Okay, yes. Okay, good. Okay, so we got some people that know how to read these type of graphs. All right, so this right here, remember we're looking at domain. That means we're looking at the x-axis. Okay, we're looking at the x-axis here. Now here, this line is going, this has a line. That means it's going to negative infinity here. So negative infinity. Okay, so negative infinity. And then it stops here at -3. So negative infinity to -3. So right now, C and A is not going to be real because you see how they have these breaks? So it can't be all real numbers because it has spaces in between. And then C is out because it doesn't go from negative infinity to -3. Okay. Now we put a little U for union. Here it's starting at -2 and it ends at 1. So -2 to 1. You guys, because it's closed circles, you have to use the brackets. We always use parentheses with the infinity because it's not an actual real number. So that's why we use parentheses. Now, if this was an open circle, this would have to be a parenthesis and not a bracket. Okay, so brackets means you include the number. It's closed circles. I just wanted to explain that, okay? Then here we start at 2. And we go all the way, it's going to go all the way to positive infinity. So D is our answer. Okay. Wait, I'm doing this right now. I'm confused about the open and closed circles. Good, King. So that's I just wanted to explain that. Open circles means you do not include the number. So you have to use parenthesis. Closed circle means that the number is included. So you have brackets. So basically, when you go to inequalities, they'll be like, you have to be 17 years or older to get into the movie theater, right? Well, it's a closed circle at 17 because I can just get in. I just turned 17. That means I'm good. But if I'm 16, I have to do an open circle because I cannot get into the movie theater. I have to be 17. So that's how you kind of change it to real life, whether it's closed or open, if that makes sense. Okay. All right. Yes, Maddie, this is Algebra 1. That's what we're doing. Yep, you're so welcome. Okay, so don't worry if you guys are still confused. We're going to keep on getting more and more. We got more and more to figure out the domain and range, okay? So somebody asked, what would the range be for this one? Beautiful question. So the range for this, right? If we're talking about range, I'm going to put it on, let me do it on a separate piece of paper real quick. So if we were doing the range, and we were looking at the y's, okay? So we're looking at the y-axis. So here it's going down to negative infinity. And then it goes all the way up to, what is the y value here? Let me see it in the chat. What's the y value for this point right here? What's the y value? 0, 0, 0. Perfect. Yes. When you see a point right here, 0 is the number on the y. So it would be 0. And it's a closed circle. So we use our bracket. Union. Now, does everybody see how it jumps up to 1 on the y? So we would have a bracket 1. And then the 1 goes all, see how it's still 1 here? It goes all the way up to positive infinity because it just keeps on going up. So this would be the range. Okay. Great question. Great question. All right. So number 8. Got it. Thank you. Yep. You're so welcome. So let's find the domain and range of the function. So what is the domain? -2, 0, 2, 4. Beautiful. Remember, because you got to know what domain means. It means for the x's. So we're just listing them off. -2, 0, 2, and 4. Perfect. The range has to be the y's. So we would go, usually we list them in like least to greatest. So -6, -4, -2, and 0. That's our range. Okay. Good. So we learning domain and range off of equations, off of graphs, off of tables. So wonderful, you guys. All right, number 9. We have another graph one. So let's first look at the domain, okay? Let's look at it from the x-axis. Hey, Jaden. Jacinda. Hello, hun. Hope you had a wonderful weekend. Okay, so number 9. What we doing with the domain? Does anybody know? Give me my money said -2 to 4. And they got the brackets. Beautiful. Let's go. Okay, so not sure? It's okay. Remember, you're looking at the x-axis. So here goes my first point, right? So my x-axis for my first point will be -2. It's a closed circle. So I'm putting that bracket. Then I'm going all the way over to the farthest side here. And this is my farthest x. There's no breaks in between. So it's going to be 4. And it's a bracket because it's a closed circle. Perfect. I saw a lot of -2 and 4s come in. Beautiful, you guys. Now our range. Remember, we're looking from the y-axis. So I'm looking from here. Can you guys put the range in the chat? Domain is the points on the x-axis. Black Knight, great question. 2 and -3. Let's go. Yes, -3 and 2. Yes. Remember, we always write range from least to greatest. So here is our lowest point on our range. So it's going to be from -3, comma, and it goes all the way up to 2. Good job, you guys. Wonderful. It's always on a bracket? No, it's only on a bracket here because of the closed circles. If these were open, it would be parentheses. Great question. Okay. All right, let's go to number 11. Okay, problem number 11. It says find the domain and range of the function. So let's do our domain first. Yes. I know I have a lot of uploads that I have to do to get them up on mine. Because I went live a lot last week. I just got to post them and download them. You know, it kind of takes time. What are inputs and what are outputs? Beautiful question. Exactly. It says, how do you know when there are closed circles and open? Michelle, we know, because it will say it right here. Like this is a closed circle because it's filled in. If it was open, it would be like just a circle like this. And it would be open space. Okay. All right. Inputs. Inputs are another form, another way of saying domain, another way of saying x's. These are the inputs. So this is our domain, which is 1, 2, 3, 4. So inputs, domain, x's, x-intercepts, roots, those all are referring to the x value of the function. Range is your outputs, which are your y's. So we would say -6, -3, 0, and 3. So that's another way of saying them. And that's what usually throws people off in math, right? It's like, what? I know what x's are, but I never heard of them as inputs and outputs, right? That's what math does to us. It's like be so easy, and then they just throw in one word to confuse us. So, yeah. Oh, thank you. Yes, I hated this in algebra. Yes, for real. It says, if there are arrows, do we use parentheses? Thank you, Carol, for the roses. If there are arrows, do we use parentheses? Oh, great question. I get your question. So let's go back to here. So you see how this was an arrow? We're only using parentheses here because it was going to negative infinity, and negative infinity is not a real number. So that's why we use parentheses here. So yes, I guess if you're describing as negative infinity to positive infinity, you have to use parentheses around there. Yeah. I guess I don't have one where they have open circles. I should do that. I'll make that on the next worksheet. Yeah, I didn't do open and close so much on this. I just really wanted people to focus on the domain part. The open and close circle is more on the inequality part. But I do have those worksheets as well. So, okay, number 10. It says, find the domain and range of the function f of x equals x squared plus 1. Okay, if we have a visual of this. Oh, good. You're doing this in algebra too? Okay, so wonderful. So what type of graph is this, you guys? What does that look like? Does anybody have a picture? Is it a line? Is it a U? Is it a V? Is it a half curve? What does this look like when you have an x squared? Parabola, parabola, parabola. Beautiful. A U shape. Yes, it is. Okay, so we know the U shape is going up because this X right here is positive. And then this is telling it moved up one spot. So it's going like this. This is what this graph looks like. So, domain. Let's look at the domain. Remember, that means we're looking at the x-axis here. So for here, this graph is going to continue going to the left because it has arrows. So it's going forever to the left. And then here it's going to the right forever. Okay. It will just continue going to the right forever. So it's all real numbers. Now, another way we could say all real numbers is from negative infinity to positive infinity. That's another way you could say that, okay? Either way of these will work. Now, let's talk about the range. Where is it starting at on this y-axis? 1. Good. Yes. 1 to infinity. Perfect. Remember, it's starting here at 1 on the y-axis. And since it's a closed circle, we have a bracket. And then see how it's going up? See how these are going, this parabola is opening up forever? That's to positive infinity. And so that will be our range for that equation. If you're in college algebra, please, the best thing that you could do for your life, and I say this with all honesty, is if you memorize, look up Google parent graphs. If you can memorize your parent graphs and what they look like in your head, when they're asking you what's one-to-one function, is it a one-to-one? Is it a function, right? All these type of different questions. If you have these pictures in your head, you'll be able to see it right away without doing any math, just based off of the graph. And that's what really transformed my college algebra class, is when my professor made us memorize the parent functions. And then the rest of the year, it was like, boom, 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 easy peasy. But so many students struggle because they don't have those parent functions memorized. They don't even know what it looks like. So all real numbers need a bracket. All reals. No, when you just say all real numbers, you don't use brackets. But when you do negative infinity to positive infinity, you have to use parentheses. Oh, pre-calc, you don't like it? Okay, let's do number 12. So let's do the domain, y'all. Domain. Remember, we're looking at the x-axis. And we want to start with our farthest to our left. Okay. So let me see. Does anybody get it? -4 to 3. Ooh. See, when it's discrete, this is called a discrete. Okay. You talk about continuous and discrete. This is discrete because they do not connect. So unfortunately, we have to list off. So -4, you guys are correct. Here is -4, but you also you can't say -4 to 3 because they're not all connected. So you actually have to list off. Here we would have a -2. Here we have a -1. Because -3 is no point. There's no domain in that -3. Here we have no point at 0. 1 is right here. And then we have 3. That's our domain. So this is called a discrete function. They do not connect. So when they do not connect, you have to list them out like that. Does that make sense, everybody? Does that make sense? Yes, yes, yes. Good. Okay, perfect. Versus, I just want to make sure everybody could see that. See, here we could do this because they all were continuous. From -2 to 4, it's continuous. There's no breaks. Okay. So now let's talk about the range. Remember, we're starting from our lowest, our least, to our greatest. So can anybody tell us what our range is? Black Knight said -4, -2, -1, 2, and 4. Okay, Black Knight, let's go. Okay, so here we have -4. Here we have -2. We have -1. We have a 2 here and a 4 here. And that is our range. So you see how the arrows look different from when you're going from range from when you're looking from the domain. See how the domain goes up or down versus range goes left and right. Okay. All right, beautiful. Okay. We got another equation. Kind. And you know, my worksheets, if it's on the ACT, this is an ACT. We do the ACT, not the SAT out here in Wisconsin. If it's going to be on the ACT, you're going to see it on my worksheets, right? I want to give you as much experience with the terminology, how they break it down. Okay. So, 13. Find the domain and range of the function. Okay. What type of graph does this look like for number 13, you guys? Is it a U? Is it a curve? Is it a straight line? V. Yes. This is absolute value. It's a V shape. Upwards, okay? V, up, because it's positive out here. So let me just give you a little visual. So this is X, this is Y. So we know we're doing a V. It says to drop down 2. 1, 2. We're going to put our point here, and we're having a V, V. Okay? It's a V. And we know it's going up. Okay. With our graph, now can people see what the domain is? What is the domain here? Would it be a line if there isn't a variable? Yes, it would. If this was gone, yep, it would be a horizontal line. That's the base graph for this absolute value. That's why it's a V. Good. Everybody's saying negative infinity to positive infinity. Perfect. It's going to go all the way to the left, and it's going to go all the way to the right. This is going to keep on going, slowly but steady, and it'll just go all the way to the left to infinity. That's our domain. Now the range. The range, where does it start at on the Y? It starts at -2. And then it goes all the way up. See how it opens up to positive infinity. Good. Okay, it's starting down here at -2. Okay. Well, let's go to 14. So if we want to find the domain and range, this is a U of this parabola. What does the closed bracket mean? Closed bracket means that it includes that number. That's where it starts. It's not an open circle there. It includes it. Oh, perfect. Somebody said that. Good luck on your test. I hope you knock it out. I hope you do good. Okay, so let's find the domain. What's the domain? What is the domain, you guys? Negative infinity positive to negative infinity. Beautiful. Good. Oh, I see a lot of people saying 2. Okay, even though, look, I know you guys are saying 2 because it's on the x-axis, right? But you have to look at where it's going. See how this is going down forever and ever and ever and ever, and it's going to cross? Eventually it's going to be going. See how it's going? See how it's going past the 6? If this continues to go down, 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 down forever, it's going to eventually go all the way to negative infinity. Here, it's going past 2. See how all this goes past 2? And it's going to keep on going over and over and over to positive infinity. That's why we can't just say 2 because it doesn't stop there. It goes past 2 and it keeps on going to positive infinity. And then it goes past the 2 here and it keeps on going to negative infinity. That's our domain. Now our range, remember we're looking at the y-axis. So my range starts right here. Can you guys put in the chat, what's my value right here on the range? Hey, Assassin Wolf. 0, 0, 0. Yes, it is 0. A lot of people want to say this is 2, 2. No, no, no. We're not looking at the X. We're looking at the Y value. So this point is 2 comma 0 here. But remember, when we look at the range, we only looking from the 0. So this would be 0. And then it's pointing down. So it's going to go from, oh, I wrote this wrong. Let me rewrite it. So it's going to go from negative infinity all the way up to the highest it can go is 0. Well, that should be close. Any questions on that? Because it doesn't go past. See how we don't have no y above that? There's no, this function never goes past this 0 value on the y-axis. H said, wait, how did you get that again? Good, H. So here, we're looking at the y value for this point is 0. That's the highest it will go. Then since it's pointing down, it goes all the way down to negative infinity. So we're saying the y's is going to be negative infinity all the way up to 0 because this is called the maximum. That's the highest it will go on the y-axis. Oh, thank you, Carmen. This is hard, you guys. I'm telling you, this is not easy. And it's like, it's either like you could see it or sometimes you just can't see it. I used to struggle with this domain and range myself. So I understand like, oh, I still don't get it. Like, how come it's not 2? But it's because you're looking at it from the wrong axis. This is the x-axis versus you need to be looking at it from the y-axis. Okay. And it's okay. Sometimes we just can't get it. But at the moment, we have to just take a step back, right? Do something else, and then come try to hit it back at a later date. Okay. So 15, the ACT problem. Okay. It says, which of the following correctly describes the range of the function this? Okay, this is where I said if you memorize your base, our base functions, right? And we know a little bit of like what transformation does. So I'm going to draw this out for you guys. Here goes the x-axis. Here goes the y. Okay, we know we're having a parabola. We know we're having a U-shape. We know it's going to go up somewhere. Okay, now this -9 knows that tells us that we're dropping it down 9 spaces. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere right here, this talks about how skinny or how wide it's going to be. We're not focusing on that. We just know it's going to go up. Okay, that's our base. This is what it's going to look like. And this is -9. Remember, we're looking at the range only. So does anybody see the answer? Is it A, B, C, D, or E? What do you guys say? Hey, AMT. E, E, E. So all real numbers between and including -9 and 9. Ooh. C. All real numbers greater than or equal to -9. See, C is our answer. Now let's talk about it. Let's talk about why C is our answer. So here, we're starting at -9 on the y-axis. So we got this. Now, it's greater than or equal to. Because it's a closed circle here, we know it's going to be equal to. And you see how it's going all the way up? It's shading all the way up to infinity. So it's all real numbers greater than or equal to -9. See, the problem with E is saying it's all real numbers and including -9 and 9. Well, is it only between -9 and 9? Does it stop at +9 up here? No, it goes all real numbers, and it's just going to be greater than or equal to -9. It doesn't stop. It's a closed circle because of the equal sign here. And it's saying that it's starting at, it moves it down -9 and it's equal to that. So if we found, which we're going to jump into next, you guys, we're going to do X and Y intercepts. So if we plugged in 0 here, right? If we plugged in 0 and we found the Y intercept, oh, -9. And then, so this would be 0 minus 9, which would give us -9. So H of 0 would be, so this is saying that 0 and -9 is our Y intercept. So this is where this function starts at on the Y axis. It starts at 0, -9, and that's why it's equal to negative. That's why it's included. Okay. All right. How we feeling? How we feeling? This is not easy, you guys. This is not easy by far. So we did linear versus nonlinear. We have done, what else did we do? We did domain and range. And now we're going to jump into some x-intercepts, okay? Going to jump into some x-intercepts, x and y intercepts. All right. -7. Okay, I see -7 as the answer. So let's talk about how we find intercepts, okay? In order for us to find the y-intercept, we make the x equal to 0 and solve for y, okay? That's the process. So what does that mean? I'm plugging in 0 wherever I see an x. So here I'm going to plug in 0. So this is going to be 3 times 0 minus 7. Well, 3 times 0 is 0. And 0 minus 7 gets us -7. So our y-intercept is going to be A. Beautiful. All right. Number 3. What is the x-intercept for the equation? So does anybody know how we find the x-intercept? It just depends. I'm trying to go live every day, at least Monday through Friday, but it just really depends. Make y 0, make y 0. Good. How did you get -7? Because 0 minus 7 is -7. It's like you have $0, but you spend 7. So that's why we get -7. Good. So in order for us to find the x-intercept, we make the y, like you guys said, y equal to 0 and solve for x. So let's do that. So let's plug in, right? That means we're plugging in 0 here. So we're going to say 0 equals 3 over 2x minus 6. All right, this is where those solving equations, what we learned in the very beginning of algebra, come into play. What do we do first, you guys? How do we solve this? How do we solve for x? Add 6 to both sides. Beautiful. Yes. Remember, we're going to do the opposite. So we're going to add 6 here, add 6 here. Perfect. This cancels. And now we have 0 plus 6 is 6. 3 over 2x. All right, what's our next step? Divide, divide. Yes, we can divide. Multiply. That's what I was looking for. I want to multiply both sides by 2. Because I want to get rid of that 2 in the denominator. So if I multiply this side by 2, I have to multiply this side by 2. And then this becomes 12 equals 2. These 2's cancel out, and I'm left with 3x. Now, what can I do? How do I get x by itself? Jaslyn, you are 100% right by doing the opposite. Divide by 3. Perfect. So we're going to divide by 3, and x is equal to 4. Oh, sick. I don't have none of the answers there. I got to fix this. This was supposed to be 4. So I got to fix it. Fix that multiple choice. But yes, x is 4. So wonderful. Yes, Carmel, that's the truth, right? I was never great at math, but I really liked it. My professor was like, won't you come work for me? And that's where I fell in love with math, was like really helping people. I used to have this, like when I used to work at the community college, my community college that I went to, from a professor, like helping students that struggle. I had like a group of mothers, and they were all together, and they just wasn't getting in. And then that's where I fell in love. Like I felt like I was changing people's lives, because math could hold people back in college. Like if they can't get past that math, it could just hold them up for their whole degree. And so, yes, I totally understand. All right, let's go to number 2, you guys. So here we were given, this is called slope-intercept form, okay? All these we were doing is slope-intercept form. This is standard form, okay? So when we're trying to solve for the x-intercept, we still do the same rule. Make the y equal to 0 and solve for x. It's always the same, okay? So here we're going to plug in 0 for the y. So we're going to do 2x plus 4 times 0 equals 8. Okay, 4 times 0 is 0, so that goes away. And we have 2x equals 8. What's our last step always, you guys? If we want x by itself, what's our last step? Divide. Perfect. So we're going to divide by 2, and we get x equals 4. And A is our answer. All right. Now, often this confuses a lot of students. It says find the y-intercept of the function. Lex, yeah, I do geometry. Jaslyn, what's your question, hon? 0. Is it A, B, C, or D? What is our y-intercept? A. Let's go, Diana, Lex, Andy. Yes. It is A. So this is another way that you have to know how to identify x's and y-intercepts is off of tables, you guys. And a lot of students mix this up. But remember, if you understand how to find the y-intercept, remember when we're finding the y-intercept, we're making the x 0. Well, the x is 0 here, and this is the y-intercept. Versus this one is the x-intercept, because remember, in the x-intercept, the y has to be 0. And that confuses people a lot. But that's how you're looking at it, okay? If I'm finding the y, I make x 0. Oop, this has to be my y-intercept. Oh, you're so welcome, Give. Thank you for all the follows, you guys, and the double taps. I really appreciate it. And the comments. This is Algebra 1. Yep, this is Algebra 1. Okay. So what is the y-intercept of the equation? Yeah, it can be confusing. Thank you, Bonko, for the perfume. Thank you, thank you. Nah, this is Algebra 1 freshman year. Some 8th graders take Algebra 1, though. 4, is it 4? Good. C. Wonderful. So the y-intercept, if we look at it from the graph view, right? We're looking at where does this function cross the y-axis? Well, it crosses it right here. And C is our answer. Perfect, perfect. Now, you know we can't do math without no word problems, right? We cannot do any math without word problems. Right? It's like, oh boy, word problems. You are buying tickets for a concert. Regular tickets cost $50 each, and VIP tickets cost $75 each. You have a budget of $600 for the tickets. Okay. The equation, which they gave us here, models the total cost. So we're going to rewrite this equation. 50x plus 75y equals to 600. Where x is the number of regular tickets and y is the number of VIP tickets. How many regular and VIP tickets can you buy within the budget? Okay. So let's find out how many. So if we sold 0, what is this? VIP tickets. Okay. So let's make y 0. And we're solving for the x. Okay. And then let's make over here, let's make x equals 0 and solve for the y. Okay. So here we're going to do 50x plus 75 times 0 equals to 600. Okay. Oops, I forgot the 0 here. 50x. This cancels. 0 times anything goes to 0, right? So this going to cancel out. And we have 50x equals to 600. We need x by itself. And whenever a number is attached to a letter, they're multiplied. So to undo that, we have to divide by 50 by 50. This cancels and we get x equals. Okay, this 0 is going to go away. You can always cancel out a 0 over 0. So 60 divided by 5 is going to give us 15. Am I right or am I wrong? I think I'm wrong. How many times is 60? 12. Thank you. Thank you. 12. I knew I was too high. 12. 12. Good. So if we bought 0 VIP tickets, we can buy a max of 12 regular tickets. That's what that's saying. We could buy a max of 12 regular tickets if we bought 0 VIP tickets. Now, let's say we only wanted to be in the VIP club. We going out fancy, right? Well, let's see over here. Let's see how many VIP tickets we can get, how many people can come. And we only got $600. So we're going to do 550 times 0 plus 75y equals 600. Okay, this cancels. And then we're left with 75y equals 600. Divide by 75, divide by 75. This cancels and we get y equals. Can somebody do that for me? What's 600 divided by 75? Jaslyn, thank you. 8. Thank you, thank you. So 8. We can get 8 VIP tickets. If it's 12 of us and we go on regular, 12. Wonderful. Any questions on this word problem? Any questions? Okay, what are you confused on? Let me know. What's the question that what's confusing you? The plugging in 0 or what? Oh, thank you. Yeah, V Parker said that wasn't bad at all. Nope. They do use a lot of words to confuse you. Where the canceling out comes in. Oh, okay. No worries. So 75 times 0 is just 0. So we could say 50x plus 0, but 50x plus 0 is just 50x. So that's why I say it just cancels out, because 75 times 0 just goes to a 0. And it leaves us with just 50x. Same thing here. 50 times 0 is 0 plus 75y equals 600. Well, 0 plus 75y is just 75y. The 0 comes from us finding out how much regular or VIP tickets can we buy within the budget. So we're saying, okay, if I just want to know what's the max amount of regular tickets I can get without buying no VIP, I would plug in 0 here. Versus, hey love. Versus over here, if I want to know just how many max VIP tickets I can get, I would make the regular tickets 0. That's why we're plugging in 0 there. Oh, thank you, Parker. Thank you, thank you. Thank you. Yes. All right, number 6. So what are the x-intercepts of the equation? What do you guys say about number 6? What are the x-intercepts? 2? Good. Okay. So you got 2 as 1. This is perfect. But you also got to ask yourself, where else does the function cross at? Don't it cross right here too? But just by you saying 2, you know you could, see, so you got 2 here, 2 here, 2 here, 2 here. So we couldn't eliminate anything. But here, do you guys see it now? Good. Lady J said C, negative 1.5. Yes, it's C. See, we can't choose negative 2 because that's over here, right? So that's why D is out. And then this is out. This is out. It's negative 3 is way over here. Okay. So C is our answer. Beautiful. It's between negative 2 and 1. Negative 1. All right. Good. Okay, so number 8. It says find the x and y intercepts of the function. Okay, y'all tell me what the x-intercept is. From the table, what are the x-intercepts? Yeah, and that's why I made this worksheet. So literally you can see how to find the x-intercept, because you got to know how to do it from a table, word problem, pictures, graphs, all of it. So negative 1, 0. Mama, 1 and 0, 1 and negative 1. Let's go, mama. So, yes, you guys all said this is the x-intercept. But hold up, hold up. That's an x-intercept too. So -1, 0, and 1, 0. What is the y-intercept? Does anybody see what the y-intercept is? Carmel, yes, -4. Let's go, Lady J, yes. So this is our y-intercept here. It's the only point that has 0 for the x, 0, -4. So this one had 2 x-intercepts and 1 y-intercept. And a lot of times you'll find that with parabolas, absolute value equations. These use, okay. Let's do number 9. So number 9, we want to find the x and y intercepts. Jaslyn, I got you. Oh, by the way, you guys, if you need help, if your child is struggling, they need tutoring, you guys can always email me at impactmath19@gmail.com or click the link in my bio to sign up for a one-on-one session. Okay, I did want to say that. Good. So Perez Smith said 4 or 5. Okay, so which one is which though? The brat, I got you. Don't let it stress you out. Come get that help. So what's the x-intercept? Let's just focus on the x-intercept. So where does it cross the x-axis? Yep, Ray. I teach all the way up to college algebra. Thank you for the gift, love. 0445. Ooh, we kind of all over the place with this. So for the x, if we're trying to name that point, because remember, we're looking for the point that's on the x-axis, this would be 4, 0. The y-intercept is where it crosses the y-axis, which is right here. So it would be, what's the x value? 0, 4. Yes. Yes. All right, you guys. My baby just woke up, so I have to call it a session. Thank you so much if you've been here with me for the whole entire time. I appreciate you, heart you. Thank you for all the comments. Hopefully I'll catch you guys on live tomorrow, Tuesday. I don't know what time I'm going on Tuesday, but Wednesday for sure I'll be on around 10 o'clock, 11. Same time. Thank you so much, you guys. Have a wonderful night. Bye.